Dear students, today we will discuss Newton's first law of motion. And in order to understand first law of motion, let us recall some history. How did this first law of motion was introduced into the physics? तो पहले एरिस्टोटल के टाइम पर people used to believe that any object which is moving needs force to move it, to keep it moving, even if it is moving with constant velocity. If the object is moving with constant velocity, there must be some force acting on it. It was believed earlier. However, Galileo proved everyone wrong. He took two inclined planes, as shown in this figure. He dropped a ball from certain height, say that the height is h, and when the ball was released, it was observed that ball reaches at the same height on the other side. Then he did some more changes in this activity, and on the right hand side, the inclined plane on the right hand side, he changed the angle there. So instead, suppose let us take initially the angle was 60 degree. Then on the right hand side, he took angle 45 degree. He observed that again the ball reached at the same height, but now the ball covered more distance. He again decreased the angle and keep on decreasing it, and every time he observed that ball which is the same height but it covers more distance. So what if the angle is reduced to 0? If the angle is reduced to 0, it implies that ball will keep on moving in forward direction. It will keep on moving, and here no force is acting on it. Without even any force, the ball is moving in one direction. So Aristotle's belief was shattered. It is also known as Aristotle's fallacy. So he proved that no force is required to keep a body moving if it is moving with constant velocity, if it is in uniform motion. So Newton said that any object which is in rest, which is in the state of rest or uniform motion will continue its state of motion, will continue its state of rest or uniform motion until an external force acts on it. Until an external force acts on it. This is Newton's first law of motion. मतलब जो चीज रेस्ट में है रेस्ट में रहेगी, मोशन में है यूनिफॉर्म मोशन में तो यूनिफॉर्म मोशन में रहेगी, जब तक कोई एक्सटर्नल फोर्स ना लगे, कोई बाहर से उसको ना रोके, कोई बाहर से उसको धक्का ना दे चलाने के लिए, तब तक जो जैसा है वैसा ही रहेगा. रेस्ट में है रेस्ट में रहेगा, मोशन में है मोशन में रहेगा. दिस इज न्यूटन फर्स्ट लॉ ऑफ मोशन. अगर हम मैथमेटिकली कहना चाहें तो मैथमेटिकली हम कह सकते हैं कि इफ एक्सटर्नल फोर्स इज 0, if external force is 0, then initial velocity will remain equal to final velocity. This is Newton's first law of motion. Let us consider this example. The figure is on the right hand side. You must have played at carom. If you strike hard on striker, you must have seen that carom coin, the lowermost carom coin, is replaced by the striker, and the other carom coins they remain undisturbed, they come down. So because force was applied on the lowermost carom coin, other carom coins wants to remain in state of rest. They were in rest, that is why they all came down in the same position. So in this example we see that it happens because the carom coins were in rest, they tend to remain in the state of rest. This property of the material to remain in their state of rest or motion, the tendency of the body to remain in its state of rest or uniform motion is called inertia. This is also called inertia, the tendency of an object to remain in its state of rest or uniform motion. Let us consider this example again. We have a glass, over it we have a cardboard and a coin. If you flick the card hard enough, you'll see that card goes away, whereas the coin above it comes down. Why is it so? It happens because the coin wants to remain in state of rest. It was in the rest. Right? So we have seen these two activities. Now let us discuss some questions from your in-text exercise questions. There is one more thing which we must know, that what is the difference between mass and inertia. You must remember, more is the mass, more will be the inertia, or more will be the inertia, more will be the mass. Mass is the measure of inertia. Mass is measure of inertia. So heavy body will have more inertia, lighter body will have less inertia. So question number 1 is based on that. Which of the following has more inertia, a rubber ball or a stone of the same size? The answer is stone, because it has more density and it is heavier. A bicycle and a train, obviously train. A 5 rupees coin or a 1 rupees coin, depending on which is heavier. We generally know that 5 rupee coin is heavier, so it has more inertia. In question number 2, we have an example in which a football player kicks a ball to another player of his team, who kicks the ball towards the goal. The goalkeeper of the opposite team collects the ball and kicks it towards the player of his team, of his own team. Also identify the agent supplying the force in each case. So player hits the ball, kicks the ball, the velocity will change. Another player kicks the ball to the goalkeeper, velocity changes. Goalkeeper stops the ball, velocity changes 3 times, and then the goalkeeper passes it on to his player 4 times, the velocity changes. And each time when the first football player, he is the agent, then his teammate is the agent, then the goalkeeper is the agent, then the player of the goalkeeper team is the agent who is applying the force. Simple. Let us move on to the next question. In the next question, it is asked that explain why some of the leaves may get detached from a tree if we vigorously shake its branch, because some leaves are very old and they are not attached tightly enough. So when you shake the branch comes into motion, but those old leaves, they want to remain in rest. That is why the connection between the branch and the leaf, it breaks down and the leaf comes down. So because of inertia, first law of motion. Now let us discuss another question. Why do you fall in the forward direction when a moving bus brakes to a stop, and fall backward when it accelerates from the rest? Let us assume that we are in motion, the bus is moving, and suddenly bus driver applies brake. Your lower portion, your foot, which are in contact with floor, they come at rest, but your upper portion wants to remain in motion because it was earlier in motion. So because of that, you feel sudden jerk in the forward direction. Thereafter, you can similarly explain the reason behind the backward push when the bus accelerates. Now let us move on to some exercise question. In question number 1, it has already been discussed. Question number 2, when a carpet is beaten with a stick, dust comes out of it, because when you beat the carpet with a stick, the carpet comes into motion, whereas the dust particle, they tends to remain in state of rest. That is why they come down. Why is it advised to tie a luggage on the roof of a bus with a rope? Because if it is not done, then when say that vehicle bus will accelerate or it deaccelerate, or when it changes the direction, in that case your luggage will fall down because of inertia. In next question, a batsman hits a cricket ball which then rolls on level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because there is a force on the ball opposing the motion. That is, the frictional force is acting in opposite direction. Because of that only ball stops. Otherwise, if the surface is frictionless, the ball will keep on moving, whether the hit is hard or not so hard. So that's all for this class. In the next class, we will discuss Newton's second law of motion. Thank you.